and welcome to this week's STEM lesson. This week we will be following up earthquakes by learning about a tsunami. Now we're following with a tsunami because a lot of earthquakes that happen out in the ocean can cause devastating tsunamis along coastal towns and countries. So a tsunami occurs when something moves the sea floor. They are typically larger and more destructive than a normal wave caused by wind. An earthquake, an underwater landslide, or a volcano each has the power to disturb the water all the way from the surface to the sea floor. Now behind me today, I found an image of the largest wave ever surfed. Now this would be a tidal wave and not a tsunami wave, because a tsunami wave could not be ridden. Now right here, this tiny little speck right here, is the surfer on a 114-foot wave. The top of the wave is all the way up here. It's crazy to think, but yes, he surfed it all the way through and survived. Now, since tsunamis can be so deadly, scientists and engineers have developed ways to detect them before they reach the coast so that people can be warned. The U.S. West Coast is monitored by the National Oceanic and Atmospheric Administration, or NOAA, and the Deep Ocean Assessment and Reporting of Tsunamis, which is referred to as the DART system. The DART system consists of a bottom pressure recorder, referred to as a BPR, which is simply a sensor that sits on the bottom of the ocean and detects small pressure increases that indicate that a tsunami has just passed over. Now the BPR on the ocean floor communicates the data it collects to a buoy, or a floating device in the ocean, on the surface. The buoy relays the information to a satellite that transmits the data to the tsunami warning centers. Since tsunamis can only be detected and not prevented, engineers are designing structures that can survive the destructive forces of a tsunami. When designing a building to survive a tsunami, engineers must consider where the house is, how it's orientated, what it's made of, and of course its shape. For example, a group of engineers worked with the Bureau Happold engineering firm in England to design a house that would be more likely to survive a tsunami. Well, how did they do this? They came up with a design that allowed the tsunami to flow through and under the house, which keeps the energy of the wave from knocking the house over. The engineers also decided to construct much of the houses from cinder blocks, which are much stronger than wood, usually used to build homes near the coast. As engineers become more aware of how a tsunami works, they are better prepared to create new tsunami-resistant structures, as well as new devices for detecting tsunamis that can save many lives when the next tsunami strikes. Now, the word tsunami comes from the Japanese words for harbor, su, and nami, meaning wave. A tsunami is an ocean wave that results from a large displacement of the sea floor. Tsunamis range in size from just 3 feet high to more than 1,000 feet high. The tsunami that struck the Indian Ocean on December 26, 2004 had a maximum height of more than 100 feet when it struck the shoreline. Now this one tsunami was our most recent, devastating, biggest tsunami recorded. Now the waves we typically see in oceans, lakes, and other bodies of water are usually formed by the wind. These waves are just disturbances of the surface and do not extend more than a few feet below the water. Tsunamis differ from normal waves in that they are disturbances that stretch all the way to the ocean floor, which can be miles deep. Now the big difference between a regular tidal wave and a tsunami wave is that when a tidal wave comes in, It comes in and it pulls the water gently back out. Now with a tsunami, it has all the force of that shock wave coming with it, that it does not come in nice and smooth and recede. It comes straight in and keeps plowing in through land. So what causes a tsunami? A tsunami is formed when the sea floor moves abruptly, such as an earthquake. This usually caused by an earthquake, but can also be caused by volcanoes and landslides. Tsunamis resulting from an earthquake are formed when the sea floor moves violently upwards as tectonic plates slide against each other, as we learned last week. The sea floor moving upward pushes the water above it upward also. When the water is displaced and begins to move upward, this causes a ripple that spreads out from the epicenter in much the same way that the ripples spread out from a pebble thrown into a pond. This ripple is typically no more than a few feet high and is barely noticeable to someone in a boat. The speed of the tsunami depends on the depth of the ocean, but typically they can move at about 500 miles per hour. As the tsunami gets closer to land, the depth of the water decreases, so the energy from the wave gets compressed. This causes the wave to slow down and increase in height. By the time the tsunami reaches shore, it has slowed from 500 miles per hour all the way down to around 30 miles per hour. But as the wave hits the coast, it usually does not come in as a smooth wave like the ones you see a surfer ride. Tsunamis usually form a bore along the front edge. A bore is a violent churning mass of water. Behind the bore is a large swell of water that floods the coastlines. Now, as I mentioned before, besides earthquakes, tsunamis can also be caused by volcanoes or landslides. The tsunamis resulting from volcanoes occur when the volcano is near an ocean or under the surface of one. The tsunami forms when debris, lava, or pyroclastic flow from a volcano displaces the water. Underwater landslides can also cause tsunamis. When a large chunk of land shifts underwater and some of the water is pushed up and some is pulled down, this creates a ripple in the water that will eventually become a tsunami. Most tsunamis can go unnoticed. Only those that kill a lot of people gain public attention. For example, during the last 100 years, there have been more than 200 tsunamis in the Pacific alone. Thank you for joining us for this week's STEM lesson, and be sure to look for next week's. Thank you and have a great day.